Okay, now we'll see. We know how to calculate the probability of error and bit error rate, or the bit error rate or probability of error depends upon what parameter, and all these things we'll see. Okay, now we'll solve one question based on this probability of error, and now we'll see the classroom workbook question number 2. Now here is the question. Consider a binary digital communication system with likely zeros and ones, and he is giving, see, one important point here, take a note, take it as a note. In the question equiprobable is given. In the question, if equiprobable is given, consider it as uniform distribution. In the question, equiprobable is given, consider it as uniform distribution and not consider as Gaussian distribution. In the question, if equiprobable is given, consider it as uniform distribution and it is not considered as Gaussian distribution. Okay, but generally the binary one and data is transmitted in the noise. The noise probability density function is Gaussian distribution. So how we are solving the probability of error calculation, in the same way actually we are taking Gaussian distribution. But in the question, if it is mentioned equiprobable, consider its distribution as a uniform distribution. Okay, you know all the distributions and everything. Now let us see the question. Consider a binary digital communication system with likely zeros and ones. When binary 0 is transmitted, the detector input can be lies the values of -0.25 to plus 0.25. Now this is the for binary 0. Okay, now this is for binary 0. Now when binary 1 is transmitted, a voltage detector detects the levels of (0 to 1 volts). Okay, now this is the probability density function of binary 1, 0 to 1 volts. So what I am saying here in the question is mentioned equiprobable. So you don't consider as a Gaussian distribution, you consider as uniform distribution. What is uniform distribution? Now this is the limits, A, B are the limits. The uniform probability density function is 1 by B minus A. So 1 by 0.25 minus of minus 0.25, which is nothing but 1 by 0.5, which is equal to 2. This is 2. Now similarly this is 1 by 1 minus 0, which is equal to 1. Right? Now in the question what he is given is, these ones and zeros are equiprobable and it is transmitting. The detector has a threshold voltage of, now you know the threshold comparator, you know the operation of threshold comparator, and this is the threshold comparator, and what is given, threshold voltage is also given. The first block of the receiver is a threshold comparator or regenerative repeater. Now one input to the regenerative repeater is noise affected binary data, and another input is threshold voltage, and he is given the threshold voltage of 0.24. Now what is the meaning of that? When any noise affected binary data strength is more than this threshold voltage, it will be treated as 1. When any noise affected binary data strength is less than the threshold voltage, it will be treated as binary 0. So therefore, now in such a situation, now you will take first threshold voltage. What is the threshold voltage? Now the threshold voltage is 0.2. What is the threshold voltage here? The threshold voltage is 0.2 here. Now see here, these are the red lines is the threshold voltage. Now the question is, when the signal strength more than this threshold voltage, it will be treated as binary 1. When the threshold voltage less than the threshold, when the binary data strength is less than the threshold voltage, it will treat as binary 0, more than binary 1. But what is the question he is asking is, what is the probability of error takes place when binary 1 is transmitted or binary 0 is transmitted? When binary 1, while binary 1 is transmitting, we want an error. If you want an error, then you should be transmit a level which is less than this threshold. This is the error region. Now while this level is transmitted by binary 1, definitely the binary 1 will be treated as binary 0. Error is taking place in binary 1. Now similarly, when the voltage level greater than this threshold is transmitted by binary 0, definitely the receiver will be treated as binary 1, but you are transmitting is binary 0, then definitely it will take the error. So now he is asking, what is the probability of error while binary 0 is transmitting? The probability of error while binary 0 is transmitting is, this is the level, okay? Or you may treat it as probability of error when x is greater than 0.2. You can get the error because this is error because when transmission is binary 0, which is nothing but 0.22 infinity fx of x dx. Now similarly, now probability of error when x is less than 0.2, which is nothing but integral minus infinity to x is 0.2 probability of x dx. Now this is the error taking place while binary 1 is transmitting, right? Now this integration is nothing but area. This integration is nothing but area. Area you are counting from minus infinity to 0.2. What is this area? Now here area is counting from 0.2 to infinity. Now this is the area. Now at this particular area, can you find the area of this is, now what is this? Now this is a rectangular. Area is nothing but, let me do it, 0.25 minus 0.2 into 2. Therefore 0.05 into 2, which is nothing but now 0.1. Now what about this? This is nothing but area of this is 0.2 minus 0 into 1, which is nothing but 0.2. So this is probability of error while binary 0 is transmitted. This is the probability of error for binary 1 is transmitted. Then what is the probability of error? What is the average probability of error? The average probability of error, which is nothing but probability of error for binary 0 plus probability of error for binary 1. Average is nothing but 2. Now this is 0.1 plus 0.2 divided by 2. This is the average. 0.3 divided by 2, which is nothing but 0.15. This is the average probability of error for binary 1, binary 0 is transmitted. This is very important question. Like that, now he is giving some threshold and this is the optimum threshold voltage he is given, and according to that sometimes he is asking to get the error, and sometimes he is asking to get error in binary 1 transmission, binary 0 transmission, or average error, like that the questions are asked. This is also called as bit error rate, probability of error or bit error rate. This is the probability of error or bit error rate. What is the bit error rate? Now, bit error rate is nothing but probability of 1, while probability of 1 by transmitting, and probability of error in 1, plus probability of while binary 0 is transmitting, and probability of error while binary 0 is transmitting, which is nothing but, now both are equiprobable. Binary 1 and binary 0 are transmitting equiprobable, right? Now these two are transmitted equiprobable. If these two are transmitted equiprobable, now which is nothing but 1 by 2 into probability of while 1 is transmitting 0.1 plus 1 by 2, and probability of error while binary 0 is transmitting is 0. So this is nothing but 0.15. Both are same. Okay, this is average probability of error or bit error rate. Now here is the same question. Question number 3, classroom workbook question number 3. Now this is a probability density function for binary 1. Both 1 and 0s are equiprobable. This is for binary 0. Oh, sorry, this is for binary 1. This is for binary 0. And binary 1 and binary 0 are transmitted with equiprobable as shown in the figure. Threshold voltage is 1 volts. Now he is given here the threshold voltage is 1 volt. Now he is asking find bit error rate. Now he is asking to find bit error rate. Same concept. Now threshold voltage is 1 volt. So let us take first, this is the threshold voltage. Now this is the threshold voltage, right? Now see here. Now the probability of error means in binary 1 when Z is less than 1 volt, then the error will be taking place while binary 1 is transmitted. Now here the threshold voltage is 1. First identify the threshold voltage such that it is easy for you. This is the threshold voltage, right? V threshold. This is V threshold, and this voltage we calculated, this is 1 by 4. Now this is when Z is greater than 1 while binary 1 is transmitting. Now definitely error is taking place. So therefore this is nothing but Z greater than 1, therefore this is 1 to infinity f of Z while binary 0 is transmitting. Now similarly, this is minus infinity to 1 probability of Z while binary 1 is transmitting. Now see here,